Hello and welcome to another math video. Today we're going to be looking at solving absolute value equations and inequalities. I'll be starting here with the absolute value of 2x minus 1 equals 5. So our process for solving this equation is really to find the two values for 2x minus 1 that will make this equation true. And what we need to have happen here is we have to take the absolute value of 5, which equals 5, and the absolute value of negative 5, which is also 5. So really it's just a more drawn out way of saying we need 2x minus 1 to equal both negative 5 and to equal positive 5. Now we go about solving these equations just like normal. We get 2x equals negative 4, and so we divide by 2, we get x equals negative 2. Here we add the 1, we get 2x equals 6, so x equals 3. So those are the two solutions for this equation. And again, what happens for both of those, if you look at the negative 2, we get negative 4 minus 1 inside the absolute value. And if you look at the 3, we get 6 minus 1, which is, of course is 5, inside the absolute value. So what happens there is we get the absolute value of 5 and negative 5 like we were looking at, which will give us the 5. Here's another example for you to try if you want to go ahead and pause the video and then resume when you are finished. So again, here what we'll do is we'll set 3x plus 2 equal to 4 and 3x plus 2 equal to negative 4. We'll solve those two equations and that will give us our two answers. And again, the reason this works is because there's two absolute values that equal 4. Here we'll divide by 3. So we want the 3x plus 2 to equal 4 and we want the 3x plus 2 to equal negative 4. Because when we absolute value both of those, we get a positive 4. And so hopefully you came up with 2/3 and negative 2 just like I did. Alright, now here we have a little bit different problem. Notice the 3 outside of the absolute value and the minus 1. So what we want to do first is isolate that absolute value. And I think on the first one I forgot to graph. We'll take a look at that this time as well, which really just leads us towards our inequalities. So to isolate the absolute value, we start by adding the 1 to both sides. We still have the 3 then, the absolute value of x plus 2, and then, sorry, not 7, that'd be 9. And then from here, in order to get rid of the 3, we divide both sides by 3. That gets us to the absolute value of x plus 2 equals 3. So now we're ready to go ahead and split this up into two separate equations. We'll be looking to find the solution to x plus 2 equals negative 3 and x plus 2 equals positive 3. From here, not much to do. We just subtract the 2. We get negative 5 for one solution. Subtract the 2 from here. We get a positive 1 for the other solution. So negative 5, positive 1. Again, nice thing about working with equations, you take those answers, you can plug them back into the original equation and make sure that that does actually work. And again here, if you want to try this one on your own, go ahead and pause the video and then resume and I'll go ahead and work through it. So here we would have to begin really by subtracting the 3. This should work out all right for us. We get the 2 times the absolute value of x plus 9 equals 4. Works out well because then when we divide by 2, we just get the absolute value of x plus 9 equals 2. So we set up our two equations. We set up x plus 9 equals negative 2. And x plus 9 equals positive 2. And again, not much for us to do here. We just subtract the 9. We get negative 11 for one answer and negative 7 for the other answer. And again, remember, the x values can certainly be negative, That's perfectly fine, and if you're ever not sure, you can always plug that value back in and check your answer to make sure that works. Alright, so here, looking for solving these equations, the extra thing we have to worry about is extraneous solutions. Now, on our previous problems, it was always just absolute value equaling a positive number, whereas now we have a whole algebraic expression there. The difference is that positive number is always a positive number. The algebraic expression is positive for some values of x and negative for others. So I'm actually going to start with this one down here with the absolute value of 3x plus 2. Our absolute value is isolated. If that were not the case, we would take care of that first. From here we go ahead and set up our two equations. I'm going to do the opposite of 4x plus 5 here. And then do just the 3x plus 2 equals positive 4x plus 5 here. So with the negative, make sure you distribute that all the way through. Nothing much to do on the 3x plus 2 at this point, but we get negative 4x minus 5. Now, again, this is kind of our classic equation solving. We've got variables on both sides. I would always recommend for this particular setup to add the 4x. Again, there are those four things you could do to get you one step closer, but that to me is the best step. Subtract the 2 gives us 7x equals negative 7, so x equals negative 1. We think, anyhow, again, we'll have to check for extraneous solutions. And I'll just solve this other one first, and then we'll look at the extraneous solutions. See, so here I would actually choose to subtract the 3x. So we get 2 equals x plus 5, subtract the 5, and that will tell us that negative 3 is x. So it looks like we've got negative 1 and negative 3. Again, we would have to plug those back into the original to check them. And again, we don't really even have a choice because there could be extraneous solutions involved. There is a bit of a trick that you can use, although you are going to want to know just how to plug that back into the original and make that work. If I start with the negative 1, again, if I plug a negative 1 in here for the x's, here I'd have negative 3 plus 2 on that side. So negative 3 plus 2 would give me negative 1. Absolute value of negative 1 is positive 1. And here I'd have a negative 4 plus 5, which would be 1. So that works out. And again, notice this side ends up being positive. That's important. Talk about that in just a minute. So that one appears to work. If, on the other hand, instead of negative 1, we put in that negative 3 instead, now on the left-hand side we get negative 9 plus 2, which would be a negative 7. Of course, the absolute value of that ends up being 7. So we get 7 on the left, or absolute value of negative 7, however you want to think of that at this point. And then on the right-hand side, we get negative 12 plus 5. So we get a negative 7. The problem we end up with is we've got the absolute value of negative 7, which is a positive 7, equaling a negative 7, which does not work. So that x equals negative 3 is what we call an extraneous solution. So we put a big X through it for extraneous. So again, that's kind of the basic way for checking that. There is a trick. You can really just look at the non-absolute value side. And in this case, seeing that that gives you a negative 7 like we had here, shows you that that will actually be extraneous without having to do the rest of that. Again, go ahead and try this one at the top here, and then go ahead and pause that and I'll resume and I'll go ahead and go through that one. Alright, so I just redrew this one down here so I'd have some room to work. Again, we set up our two equations. I'm going to go ahead and do the opposite of the 7x plus 14 right away there, and then do the just 7x plus 14 on this side. So again, we just solve these two equations. We'll see what happens. And again, we'll have to check for extraneous solutions because 7x plus 14 would be negative if x were less than negative 2. Let's see, on the green one over here, first thing I'd want to do would be to add the 7x. Gives me 12x minus 2 equals negative 14. Add the 2. We get 12x equals negative 12, so it looks like x is negative 1. Now, you might not have really noticed it, but I mentioned again that 7x plus 14 would be negative if x were less than negative 2. So the negative 1 is just fine. Let's see, if we look at the 5x minus 2 equals the 7x plus 14, this time I would choose to subtract the 5x. Again, I like to keep that variable positive if possible. So we get 2x plus 14. Subtract the 14 then. So negative 16 equals 2x. Divide by 2, and we get x equals negative 8. Now again, I mentioned earlier that if x was less than negative 2, then the 7x plus 14 would be negative. So that negative 8 is the extraneous solution, so we put a big x through there. Again, you could take the time to plug the two answers back into the original equation, make sure that they work. Again, my shortcut again just focuses on the non-absolute value side. In this case, I'm curious in what makes 7x plus 14 greater than or equal to 0. So we would subtract the 14, divide by the 7. So as long as x is greater than or equal to negative 2, we don't have an extraneous solution. So negative 1 is greater than or equal to negative 2, negative 8 is not. So that's how we know the negative 8 is extraneous. And that brings us to solving absolute value inequalities, specifically looking here where the absolute value of A is less than B, and in these cases actually B has to be positive. There are a few different ways to do this. I'm going to go with the kind of simplest one, which is to take the inequality and change it into an equation. Once we solve that equation, then we can figure out what the inequality would be. And I'll show you how we would do that. So just like before, we'll solve the two equations, setting 2x minus 1 equal to negative 5 and to positive 5. If we add the 1 to both sides here, we get 2x equals negative 4. Divide by 2, we get x equals negative 2. Add the 1 here, we get 2x equals 6. Divide by 2, we get x equals 3. So again, that's the solutions if that were an equation. Being that it is an inequality, what we do then is we make a number line. It doesn't have to be fancy or anything like that. Make sure I've got my points there. I'm going to put open circles here at negative 2 and at 3. Again, those are open because that inequality does not have the equal to. Now, what happens with these absolute value inequalities, it is either going to be this area in the middle that makes this inequality true, or the area on the outside. Okay, and as long as it is like it is in this case, it's the absolute value less than a positive, or really even just compared to a positive. It has to be one of those two things. Once you've done a lot of these, you can figure out which one it is just by looking at what's going on here. Which if you see that, that's great. There is a pattern there, so pay attention, you might see it. But a simpler way to do that without having to remember much of anything is just to pick a test point. Now I'm a big fan of using 0 for my test point because it makes calculations easy. So we'll plug that in to this original inequality and see if it works. Again, the 2 times 0 would be gone, which means we'd have the absolute value of negative 1 is less than 5, which becomes 1 is less than 5. So that is a true statement. Alright, so since that 0 is true, that tells us then that the inequality, it really goes from negative 2 to 3, or I should say between negative 2 and 3. And looking at that graph, it's fairly straightforward to come up with the inequality. It would be negative 2 is less than x, and x is less than 3. So we can write that as this compound or three-part inequality, and that's what we're looking at. So there's our solution, and we already did the graph in order to come up with that. If our test point had been false, then like I said, if the inside is false, then it has to be the outside that is true. Or reverse, if we had tested a point, say, like 4 would be false, and if we look at that even, that gives you the absolute value of 8 minus 1, so absolute value of 7, which is 7. 7 is not less than 5, that is false. So even without testing the middle, if we tested 4 and that turns out to be false, then we know that the middle has to be true. So if this is false, then the middle has to be true. Alright, so we've got the problem at the bottom there. If you care to go ahead and try that one, you can pause the video, and then when you resume, I will go ahead and work through that problem. Okay, so taking a look at this one, again, I'm going to stick with the method of changing this to an equation. So 3x minus 4 equals negative 8, 3x minus 4 equals a positive 8, and then solving those, we have 4, we get 3x equals negative 4, divide by 3x equals negative 4 thirds. Here we add 4, we get 3x equals 12, divide by the 3, we get x equals 4. So on our number line, negative 4 thirds would be over here somewhere, positive 4 would be over here, 0 would be somewhere in between. And again, 0 is not always in between, just so you don't think that that's going to always happen, but for these two problems it has been. So if I plug 0 in to my original inequality, I get the absolute value of negative 4 is less than or equal to 8. Well, so that's 4 is less than or equal to 8. So 0 being true, that's where, and this one has the equal to, so I guess I forgot to talk about putting the closed circles there. And then it's going to be the area in between. So the inequality ends up being negative 4 thirds less than or equal to x less than or equal to 4. So it looks like that. And here are our last couple of problems. These are absolute value greater than or equal to b. And again, the equal to, we'll talk about that difference. That's really just your open or closed circles for those. So I'm going to just use the same approach. So I'll set up my two equations, 2x plus 4 equals negative 6, and 2x plus 4 equals positive 6. Again, this will give me my endpoints on my number line. So if I subtract the 4 here, I get 2x equals negative 10. So if 2x equals negative 10, then we divide by the 2, and we get x equals negative 5. So that'll be one of our points. Subtract the 4 from both sides here, we get 2x equals 2. Divide by 2, we get x equals 1. So again, we make our number line, negative 5 here and 1 here. 0, again, is in the middle, and again, 0 is not always in the middle, it just tends to be there quite a bit. Now if we plug the 0 into the original inequality, we end up with, I'm just going to do that over here, absolute value of 4 is greater than or equal to 6, which of course is false, because 4 is not greater than or equal to 6. So in this case, our test point was false, and so with that test point in the middle, if that test point then proves to be false, so this whole entire area is false, that means that the true part must be on the outside. And this one has the equal to, so we'll do closed circles. So closed circles here and here. It has the equal to, and then it goes both up and down from there. Now that inequality, we're going to have to write using an OR statement. So x has to be less than or equal to negative 5, or x has to be greater than or equal to 1. And if you don't have the or, then it's not clear that you kind of understand that, so make sure that you have that there. Okay, so next we've got a problem here at the bottom. Apologize, I got a little cut off there. But I can kind of finish, so that's just a 5x plus 10, and that's just a greater than symbol, not a greater than equal, so that looks even worse. So it's absolute value of 5x plus 10 greater than 15. So if you want to go ahead and try that one, remember to solve it and graph it. If you want to pause, then I'll go through that once you're done. So again, if I stick with the same approach, I go 5x plus 10 equals negative 15, and 5x plus 10 equals positive 15. So I forgot my equal sign there. Going through solving that, subtract the 10 for both sides, so 5x equals negative 25, divide by 5, x equals negative 5, subtract 10 here, 5x equals 5, divide by 5, x equals 1. Again, I don't know why I put that in a box, it's not my end solution. So from there, again, like we've been doing, we would just go ahead and put those points on a number line. So we've got negative 5 and positive 1. These would be open circles. And let's see, so my 0 again is in the middle. Again, it's not always in the middle, but in this case, again, it is. So that's in the middle, and we end up testing that in the original. Now, if I test that up here, then this will be gone. I get the absolute value of 10 is greater than 15, so that is false. So like before, if the middle is false, then the truthiness must be on the outsides. So we would have, this part here would be where the solutions are. So again, our inequality would be x is less than negative 5, or x is greater than 1. So again, we need to have that or there. Well, thank you for watching, and hopefully you found this helpful.